When the J-11 production line fell silent a decade ago, who could have foreseen it would give rise to today's steel torrent of nearly 400 J-16 fighters? Behind this figure lies the Chinese Air Force's monumental leap from reliance on foreign procurement to full-chain domestic production. In 2015, production of the J-11 series ceased. This decision stemmed not from technological stagnation, but as a critical step to redirect resources toward the more advanced J-16. China's development of heavy fighters has always revolved around national security needs and independent technological innovation. In 1992, the first batch of 12 Su-27 fighters arrived in China, ushering in the era of fourth-generation aircraft. In 1998, the first J-11 was assembled based on Su-27SK technology, with a total production run of 397 units. Of these, 105 J-11 fighters relied primarily on Russian-supplied components, featuring a service life of approximately 4,000 flight hours and a radar detection range of 150 kilometers, limiting them to basic air superiority missions. The subsequent J-11B incorporated domestically produced materials, extending its service life to 4,200 hours with a range of 2,800 kilometers. Though initially still using Russian-made L-31F engines, it demonstrated progress in China's aviation industry. By the time production ceased in 2015, the J-11 series had delivered a cumulative total of 325 aircraft to the Air Force and 72 to the Navy. This discontinuation paved the way for resource allocation toward the more advanced J-16, ensuring optimized production capacity. During the decade-long hiatus, the J-11B maintained its utility through upgrades. Starting in 2017, select batches resumed production with WS-10A engines, boosting thrust to 132 kN and extending range to 3,500 km. The aircraft's composite material ratio rose to 20%, boosting structural strength by 15%. Its avionics evolved from pulse Doppler radar to active phased array systems, enabling detection of stealth targets at 200 km and tracking of up to 12 targets simultaneously. The recently introduced white-capped J-11BG variant features a white-painted radar dome for enhanced heat dissipation and is compatible with the PL-15 missile, which has a range of 250 kilometers. Through life extension treatments, these aircraft's service life can be doubled to 8,000 flight hours. Assuming 200 flight hours per year, they can remain operational for another 30 years. This upgrade utilizes spare parts from the J-16, reducing costs to 40% of a new aircraft and achieving a 30% parts reuse rate, demonstrating the Chinese Air Force's wisdom and efficiency in equipment modernization. The J-16 is a domestically developed twin-engine, two-seat heavy multi-role fighter. Its twin-engine and dual-seat cockpit design provides enhanced power and enables coordinated pilot operations. Visually, it features a robust frame with large winglets and a conventional twin-tail configuration. The tapered tail fin design ensures superior aerodynamic performance. The J-16's development and production pace are remarkable. It first flew in 2011, with the initial batch of 24 aircraft delivered in 2014. By 2025, nearly 400 units will be in service, achieving an annual production rate of 120 aircraft. Its core design features a two-seat configuration. The front seat handles maneuvering, while the rear seat focuses on data fusion and can even command up to 8 unmanned aerial vehicles. With a 12-ton payload capacity, 50% greater than the J-11B, it incorporates an internal PL-15 missile bay capable of striking targets up to 300 kilometers away. The aircraft is equipped with a gallium nitride active, phased array radar providing 360-degree coverage and 20% improved anti-jamming capability. Its WS-10B turbofan engine delivers 142 kN of thrust, with a maintenance interval of 1,000 hours. A modular production line reduces assembly time by 40%, with costs controlled at $80 million per aircraft. During the 2025 Zhuhai Airshow demonstration, 6 J-16s led the Attack 11 UAVs with 95% precision. The J-16D electronic warfare aircraft, developed from the J-16 platform, signifies a significant enhancement in the Chinese Air Force's electronic warfare capabilities. The D denotes the initial pinyin letter for electronic warfare aircraft. The J-16D is an independently developed new generation electronic warfare platform based on the J-16, integrating reconnaissance, attack, and defense capabilities. As an electronic warfare aircraft, it can seamlessly operate alongside other fighters to form a comprehensive airborne electronic warfare system. Externally, The J-16D closely resembles the J-16 fighter, though noticeable differences exist in numerous details. Its aerodynamic layout has also been modified based on a multi-role design philosophy. The J-16 and J-16D share interchangeable capabilities in certain functions, yet each retains distinct operational specializations. When comparing the J-16 to the J-11B, we observe significant differences in mission flexibility. The J-11B is designed for pure air superiority combat, capable of withstanding 9G loads and excelling in dogfighting. However, its single-seat configuration imposes heavy pilot workload and causes data processing delays. The J-16, as a multi-role fighter integrating maritime strike capabilities, achieved a 98% interception success rate during the 2024 China-Russia joint patrol. Aerodynamically optimized, the J-16 boasts a stall angle of attack reaching 45 degrees, 5 degrees higher than the J-11B. Its standardized weapon interfaces enable compatibility with the YJ-12 anti-ship missile. Although the upgraded J-11B can carry PL-15 missiles with a range of 250 kilometers, the J-16 employs internal stealth design, reducing its radar cross-section by 3 square meters. Production rates show the J-11 at 50 units annually, while the J-16 has increased to 120 units. With a domestic supply chain localization rate of 95%, the J-16 boasts a sensor response time of just 0.1 seconds and landing gear capable of withstanding 15 tons. In 2025, it conducted escort missions for H-6 bombers with an operational radius of 6,000 kilometers. The upgraded J-16 achieves 30% improved fuel efficiency and 20% enhanced stealth performance compared to the Su-35. In combat verification, J-16's conducting island circumnavigation flights in 2025, successfully locked onto F-35s at a distance of 180 kilometers. The J-11B formation achieved an 85% coordination rate. The J-16D electronic warfare aircraft demonstrated a jamming radius of 150 kilometers, with an 88% success rate in disrupting F-35 operations. These figures starkly illustrate the generational gap between the fighters. The J-16 not only achieves significant production efficiency gains, but also comprehensively surpasses its predecessor in combat effectiveness, reflecting remarkable advancements in China's aviation industry in recent years. The trend toward dual-seat variants began with the J-11BS, which accumulated experience through approximately 60 training aircraft. The entire J-16 series features dual-seat designs, reducing pilot workload by 20%. During the J-11B upgrade process, rear seat simulators were also installed for testing. By 2025, the naval J-11BHG adopted a gray paint scheme with a radar cross-section of approximately 3 square meters. The dual-seat design leverages specialized roles. The front seat pilot focuses on aircraft control and tactical decision-making, while the rear cockpit pilot manages the weapons systems, significantly enhancing combat efficiency and reaction speed. However, as a fourth-and-a-half-generation fighter, the J-16 exhibits notable weaknesses in stealth capabilities. With advancing military technology, its era may be drawing to a close. Some analysts suggest that with sufficient production numbers already achieved, the J-16 faces potential discontinuation, to be replaced by the J-20S, representing a qualitative leap forward. The J-20S adopts a two-seat configuration to lead multiple stealth drones in combat operations. This represents a revolutionary operational paradigm, where drones can carry various munitions or electronic equipment, functioning as aerial ammunition depots, electronic platforms, or even small unmanned early warning aircraft and refueling drones. Leveraging this cross-generational advantage, the J-20S is poised to partially replace the J-16. However, for the foreseeable future, the J-16's role remains irreplaceable. While the J-20S heralds a new era, its technological maturity, tactical application, and operational proficiency within units are still developing. From a cost perspective, the per-unit production cost of the J-16 may not be significantly lower than the J-20S, but its operational expenses are lower than those of stealth aircraft. If the J-20S carries several drones, its overall cost will rise significantly, making the J-16's cost advantage particularly evident. Modern warfare demands extreme sensitivity to the cost of combat units, as massive losses would be unsustainable. By 2035, the PLOF's heavy fighter fleet will adopt a new configuration centered on the J-20, J-16, and upgraded J-11B. By that time, The J-16's total deployment is expected to reach 700-800 aircraft, making it the backbone of China's air power. From the discontinuation of the J-11 to the large-scale deployment of the J-16, the development path of China's heavy fighter jets epitomizes the journey of China's aviation industry, from catching up to keeping pace, and ultimately achieving partial leadership.